All right, everybody, we're going to cover part one of section 1.5, polynomials and complex zeros in this video. To start things off, though, we're just going to review how to find the end behavior of a polynomial if it's in standard form, so the biggest exponents first, then the next biggest, etc., and how to find the degree and the leading coefficient first. So if it's in standard form like this, the degree is the biggest exponent, and the leading coefficient is the number in front as long as that biggest exponent term is first. So -2. Now, the leading coefficient tells us how the graph ends to the right. So a positive would end up to the right, but a negative leading coefficient, the graph ends down to the right. The degree tells us if the two ends go the same direction or opposite directions. Because this is odd, the two ends go opposite directions, so the graph will start up and end down. All right, so that's in standard form. We're going to keep that in mind because now we're going to do some questions in factored form. So in factored form, you do have the option of expanding this out, but again, multiplying x plus 4 by itself 3 times and x minus 2 by itself 2 times, it would be a lot of distributing if we were going to put this into standard form. So the goal here is how can we get the same information and even more, there's two things we're going to add in from this factored form. So the leading coefficient, as long as it's completely factored, which this one is the number all the way in the front. All right, so that part doesn't change. The leading coefficient is 2. So because this is a positive 2, we know the graph is going to end up to the right based on that leading coefficient. Now, here's what is different. The degree is not the biggest exponent when it's factored. It is what's called the sum of the multiplicities. The multiplicities are these exponents on each of our factors that has an x. So even though there's no exponent on this x, it's a 1. All right, this multiplicity is 3, this multiplicity is 2. So all we have to do is add those 3 exponents together. So 1 plus 3 plus 2 would give us 6. So what does that tell us about the end behavior? Well, even degreed functions, the ends go the same direction. So if it's going up to the right, it's also going to go up to the left. So that's our end behavior here. Now, 2 more pieces of information that we can take away are the zeros and their multiplicities. And then we're going to talk about what that actually means on the graph. Okay, so for zeros, we're just going to set each factor here equal to 0. We can ignore the exponents. So we're going to set 2x equal to 0. And then you would just divide both sides by 2. And so our first 0 is at x equals 0. I'm just going to go ahead and put a 0 right here at 0. Put a point. Then set x plus 4 equal to 0. Subtract the 4 over, and our next 0 is at -4. And then lastly, we're going to set that x minus 2 equal to 0. And we're going to add the 2 over and get x equals 2. And so that's our third 0 at 2. Now, multiplicities. All right, that's referring again to these exponents on each of the factors. And so the multiplicity on x was 1 because it was to the first. So at x equals 0, the multiplicity is 1. The 0 of -4 came from this factor, so its multiplicity is 3. I'm going to write that right here. And then x equals 2 came from right here, so the multiplicity was 2. Now, here's what we need to remember, and I got to kind of squeeze this in here, but if a multiplicity is even, then the graph is going to bounce off the x-axis at that point. So anywhere there's an even multiplicity, the graph is going to bounce off the x-axis. Anywhere that there's an odd multiplicity, the graph is going to cross through the x-axis. Okay, and so we just kind of say even bounces, odd crosses. To remember that, or EBOC, even bounces, odd crosses. So let's see what that means up here. So at x equals -4, there was an odd multiplicity of 3, so I'm going to put a C for cross. At 0, it was also an odd multiplicity of 1. I'm going to put a C for cross. And then at 2, we had an even multiplicity of 2, so that's going to bounce. Now, we already know the end behavior, all right? So this graph is going to start up to the left, and it's going to end up to the right, okay? What we can now do and this is where factored form in some ways is better than standard form, is we can get a rough sketch of the rest of the graph. All right, so we know that this graph, as I'm going from left to right, the graph has to connect to this 0, and it's going to cross through the x-axis. It's going to go down here. Now, these points are not going to be exact, but we know at some point, because there's another 0, the graph has to then turn and go up, and it's going to cross through again. Going to cross through again. Then, because there's another 0, the graph is going to come back down, and it's going to bounce off the x-axis and end up like this. All right, so it's a little tricky the first few times you do this, but anywhere that we had that odd multiplicity, the graph will cross through. Anywhere that we had that even multiplicity, the graph will bounce off the x-axis. All right, so very similar question here, almost identical, but I took out that first x. So if we look back, it was 2x to the first, and then all those other factors. This one is just 2, and then the other factors. So that does not change the leading coefficient, but it does change the degree. Because this doesn't have an x, it doesn't count towards the degree. So for my degree, I'm only going to add the 3 and the 2 here. So the degree for this function is 5. So the leading coefficient is still positive, so it's still going up to the right. But now, because the degree is odd, it's going to start off going down to the left. So that's our end behavior. We're also going to have one fewer zeros. We're not setting this equal to 0 because there's no x. Set x plus 4 and x minus 2 equal to 0. So if we set x plus 4 equal to 0, we got negative 4 in the last problem. Get that again. And then positive 2 here. Again, what are their multiplicities? Well, on 4, the multiplicity is 3. So the graph is going to cross at x equals negative 4. And at 2, multiplicity is still 2, so it's going to bounce again. All right, so putting these points up here, we've got a 0 at negative 4. We've got a 0 at positive 2. And we know the end behavior is down to the left, up to the right. And this was cross, this was bounce. All right, so to connect or to fill out the rest of this graph, again, from left to right here, the graph is going to head up to the 0 and cross through. Eventually, we don't know exactly where, but eventually the graph has to turn to come back down to this 0. It's going to turn, go back towards the 0, and it's going to bounce off the x-axis. And I kind of missed the line a little bit, but you get the point, right? It has this general shape. That's what we're looking for here, is the general shape. All right, last question. I'm going to ask it 2 different ways. One is, this is going to say less than 0, and then I'm going to ask at the end, but be greater than 0. So it says solve this inequality, and there's a few ways we could do this, but I want to use what we just learned. So I want to use this graphing technique. So we're going to start off, and we're just going to ignore this less than 0 symbol, and we're going to start by graphing this function. So first, its degree. All right, we've got x to the first, x to the second, x to the first. That adds to x to the fourth, so the degree is 4. The leading coefficient. There's nothing in front, so it's just a 1. Leading coefficient is a positive 1. All right, that tells us the end behavior of this graph. Leading coefficient is positive, so up to the right. And degree is even, so they go the same direction up to the left. Now, I'm going to skip a couple steps here because this one's not primarily, I'm not primarily focused on the graphing. But if I set all these equal to 0, okay, so if I set x plus 1 equal to 0, I get negative 1. That is going to cross through the x-axis because, again, odd exponent of 1. Set x minus 2 equal to 0, I get 2. This one is going to bounce, not because of that number there, but because of the exponent being even, the multiplicity. And then set that one equal to 0, we get negative 4. And that is also going to cross because it's to the first. All right, so if this graph starts up, ends up, from left to right, the graph has to come down and cross. Has to go back up and cross. Has to go back down towards the 0 and then bounce up, and it looks something like this. Again, just a sketch, doesn't have to be perfect. But once we have this graph, the question is asking when the function is less than 0. Well, that's the definition of negative. So we're going to use our graph to answer when is this expression less than 0 or negative. So remember, negative on a graph just means below the x-axis. So the only part of this graph that's negative is this part. And so our answer, we want to give that interval of x coordinates. And remember, intervals, we give the leftmost x first, and then the rightmost x on that interval. All right, so the leftmost x coordinate would be -4. The rightmost x coordinate on this interval is -1. So that's the interval of x values where this expression is less than 0 or negative. So that's the less than 0 part of the question. But what if it was a greater than 0? Or you know what? I'm actually going to change it a little bit. What if, instead of being greater than 0, this was a greater than or equal to 0? Greater than or equal to 0. Well, we would still sketch this graph here. But greater than or equal to 0 means either positive or 0. So where is this graph positive or 0? So it's positive here. It's above the x-axis. Positive here. All the way to the right there. So how would I list these intervals if that was the question? So I'm going to do this. I'll do it in red since I already answered that one right up there. But if it's a positive question, remember, left x comma right x. So the answer would now be -infinity, comma, we've got a 0 at -4. So -infinity to -4. But because it was greater than or equal to 0, at -4, the graph is 0. So we put a bracket to include that point. Then the graph never stops being positive or 0. So this is all one interval, even though we have a 0 right there. So I would write this part. I'm going to do a u. I'm out of space. But I'll do a u. And it's going to start at -1. And when does it stop being positive or 0? Never. So it's going to go right towards infinity. So that would be the interval if it said greater than or equal to 0. All right, but that's it. We're going to do a lot with this. I may even show you guys a second method, but this will be good for now. And the more we do this, again, if the graph is a little weird, we'll get there. Sometimes these take a little bit of time. All right, stay flawless.